Hello student, today we are going to learn all the NCRT example problem. Okay, so today we are going to learn how to solve the example problem. First we'll be learning with the 1.3. Okay, so I have different problem here. All the problems from chapter 1 example. Okay, so it's a example problem number 3. So the problem is asked how much positive and negative charges is there in the cup of water. That's the question they asked. So first we will see in a cup of water. In cup of water, what is that? In cup usually will be taken as a it is 250 gram. Okay, it's like a 250 gram. Most of the cup will be the 250 gram. Okay, so inside the cup, water will be there. Water is going to be the H2O. Okay, so we know 18 gram of water. 18 gram of water is going to be the number of molecules is the 6.02 into 10 power plus 23. Okay, it is the molecular number which is also called Avogadro number. Okay, so now we are going to learn in 250 gram of substance how much molecules will be there. Then we can calculate how much positive will be there, how many negative will be there. Okay, now see here, it is in 1 gram of substance. It's going to be 1 gram of water. It's going to be 6.02 into 10 power 23. That's going to be the Avogadro number divided by 18. It's this many molecules is there in a 1 gram of substance. Okay, actually we want 250 gram of substance. How many molecules will be there? So 250 gram is going to be 250 into 6.02 into 10 power 23 divided by 18. So this much substance will be there in 250 gram of substance. Okay, actually we have hydrogen. They asked how much proton, how much electron will be there in the water. Okay, so first we will take it as how many proton will be there. H2O will be there. H2O, it's going to be 2 proton because of hydrogen, and oxygen 8 proton. Totally we have 10 proton. First we will calculate how many protons will be there. Okay, so in 250 gram of substance, it's going to be the 6.02. It is called Avogadro number into 10 power 23 divided by 18. 18 is for the 18 gram of substance. 18 gram of water is equal to Avogadro number. Okay, into 10. Why into 10? Because in hydrogen, 10 proton, 10 neutron will be there. H2O, 10 proton, 10 neutron will be there. Okay, so here I am taken as a 10 proton into the charge of electron. They asked how much positive, how much negative will be there in a cup of water. Okay, the charge of electron is going to be 1.6 into 10 power minus 90. Okay, so this is the total number of total number of protons is there in the 250 gram of substance. Okay, so that's going to be the H2. If you are calculating this, finally we'll get the finally we'll have it's going to be 1.34 into 10 power plus 7 coulombs. Okay, so it is this much charge of proton or charge of electron will be there in a 250 gram of water. It's very simple explanation. Right now we are learning examples from the chapter 1. Okay, so they asked 250 gram of water, how much positive charges, how much negative charge will be there. Okay, it's very simple question. Okay, easily I am taken to its cup of water means 250 gram. Okay, so 18 gram of substance, it's a water. 18 gram of substance is going to be the Avogadro number. That's going to be 6.02 into 10 power plus 23. Okay, so easily you can calculate 1 gram, and also easily you can calculate 250 gram. Okay, then into 10 into charge of electron or charge of proton. Okay, that's going to give how much charge of proton or electron present is there in 250 gram of sorry, 1 cup of water. Sorry, 1 cup of water. Okay, it's the first question over. Now we are going to learn with the Next problem. Okay, first chapter example problem we are discussing. Okay. Uh, yes, sure, Pa, I'll save it. Okay. Second problem. So second problem, it's 1.5. Okay, remaining problem I'll do later. Okay, first we'll see second problem 1.5 how it's going to be. So the problem, it is the charge one, it is A, charge two is going to be the B. Okay, so it is a distance of 10 centimeter. So we'll be taken as a force F is equal to K Coulomb's law. F is equal to K times of Q1 Q2 divided by D. Okay, D is going to be 10 centimeter here. Okay, now see what's they are doing. Okay, so they made contact with another uncharged body. Okay, see here what they are doing. Okay, in this A they kept as a C as a contact, in this B they kept D as a contact. Okay, so here how many charges is there? Four charges, four proton is there. Okay, when we contact with the C, it's going to become exactly half of that. Okay, because it is uncharged, C is uncharged. Okay, when we made the contact, okay, it's going to become half of. Okay, so Q is going to become as half here. That's going to be two charges will be at the A, two charges at the C. Okay, the same at the B point. See here only two charges is there. Okay, so when we uncharged body we are making into the contact, it's going to become as the equally divided. Okay, now A is become this you are taken as Q means so A is become as a Q divided by 2. Okay, B is become also if suppose B, if you are taken Q dash, it's going to become as half of that value Q dash divided by 2. Okay, so now we'll be solving this problem. See here, it's very easy calculation only. Okay, so distance also they reduced off 5 centimeter. Okay, so according to the Coulomb's law, F is equal to K Q dash, because A we are taken Q, B we are taken Q dash divided by the distance we are taken as a D. Okay, now what's happened? Charges became off, distance is also become as the off. Okay, charges become exactly off, distance also is become as the off. Okay, after made the contact of uncharged body, the charges become off. So F is equal to K times of the Q is become as a Q divided by 2. Q dash is become as a Q dash divided by 2. It is for force new, it is for force old. Okay, it's for case 1, it's for case 2. Okay, so distance is become of D square divided by 2, it's going to be whole square. Okay, this here only you need to know how the solution is going to be. See what's going to happen. So the same force new is going to be for new situation K Q dash Q dash. Okay, just direct multiplication. 2 2s are 4. 4 I have taken. D square, 2 square will be 4. Okay, denominator directly will go into the numerator. So 4 times of K, uh, it is 4 times of K Q dash divided by D square into 4. Okay, so this one 4 is there, this one 4 is there. Denominator directly will go into the numerator. 4 get cancelled. Okay, now we'll see what is the new force is created. New force is created between the two charges is going to be K times of Q dash divided by D square force new. Okay, force new exactly equal to the force volt. Okay, there is no changes in the forces. Okay, there is no changes between the two conditions. Okay, see here, after we made the charge is exactly off, distance is exactly off. Okay, there is no changes is happen in the force. It's very simple explanation. Okay, so before condition, so case 1 I am taken this as a case 1, force old I am taken. Okay, after we made the modification we are taken as the force new. Okay, so force old is also equal to force new. Okay, after the charges became off and the distances became off, the force, there is no changes in the force of repulsion. Okay, because here plus plus will be there, it's going to be the ripple each other. It's very simple. Okay, next we'll be learning with another one, another problem. Okay, problem number 1.6. See what's going to happen in problem 1.6. Okay, there are three charges is there, Q1, Q2, Q3. There are three charges is there. Okay, So what is the resultant force acting in the based on the these three charges? Okay, most of this answer is going to be the zero. Okay, the answer is going to be zero. It's very simple answer. Okay, now we are going to see how this answer is going to be zero. Okay, see here Q1 will be taken as positive, Q2 will be taken as positive, Q3 we are taken as a positive. Okay, so at center, capital Q is there. Okay, that's also will be the positive. Okay, plus plus will get ripple. So will be taken as A. F1 force will be created at the point of O. Okay, it's going to be repulsion. Okay, if you are taken B versus O, it's also getting repelled this direction. Okay, if you were taken C versus O, it's also taking repulsion with this direction. Okay, F1, F2, F3. Okay, so this three acting is in a three different direction with the angle of 120 degree, 120 degree and 120 degree. Okay, now how come this answer is going to be zero? That's what we are going to discuss. Okay, see here how this answer is going to be zero. At single point, its F1 will be downwards, F2 will be this side, F3 will be this side. If you know Lami's theorem, easily you can tell this answer is going to be 0. Okay, the angle is going to be 120 degree because one full circle will be 360 degree. If you add together, we will get the answer as a 360 degree. Okay, now we'll be seeing, first we'll see solution for this two, then we'll do solution for everything. Okay, so first we'll do solution for two forces, F2 and F3. Okay, see here the angle between the two is going to be 120 degree. Okay, see F2 will be acting this direction, F3 will be acting this direction. Okay, first I'm going to solve this two. Okay, so this two angle will be 120 degree. I'm going to use the Pythagoras parallelogram law of vector as we learned in 11th standard. This one, okay, the resultant is going to be the resultant force. So a resultant net value. Okay, I'm taken as a R net. Okay, so it's look like I made it this look like a parallelogram. This is going to be F3, this is going to be F2. Okay, as we know the resultant is equal to root